We're doing day 2 on parametrics. We're going to talk mostly about projectile motion today. This is the big and exciting part. But we're going to have some weird eliminate t questions that you would not have thought of, okay? And we're going to spend just a second looking at inverses, because you can graph them really easily in parametrics. And then we are going to start with a warm-up on revisiting how to graph it all. So at the top of 14a, we have this question, and because Maggie was gone yesterday, we're going to go over this a little bit. X equals t squared minus 1 means to find all the x values, we're going to use that rule of t squared minus 1. And then for y, it says 2t plus 5. To find out all the y values, we're going to put them into 2t and add 5. But this is the most important thing. The t values we plug in can only go from -3 to +1. They could be decimals or fractions, but we're just going to be lazy and do the integers. So we're going to go -3, -2, -1, 0, and 1. Because they start and stop at -3 and 1, we're going to actually have endpoints to this graph. One is going to occur at -3 and one is going to occur at 1. All right, to generate the x values, we said we're going to take those t's and square them and then subtract 1. So -3 squared is 9, minus 1 would be 8. Square this would be 4, minus 1 would be 3. Square that's 1, minus 1 is 0. -1, 1 squared is 1, minus 1 is 0 again. We good so far? Okay, now this is where some students get stuck when they're in the quiz because they forget you don't look at x and you only look at t to get to the y. So you're going to put 2 times the t plus 5. So if I double this, I get -6 plus 5 is -1. If I double this, I get -4 plus 5 would be +1. Double that would be -2 plus 5 would be 3. This would be 5. 2 times 1 plus 5 would be 7. I think I got those right. Okay, so the x was based on the t and the y was based on the t. But when we go to graph it now, we only graph the xy ordered pairs. And then we're going to have to do something called orientation, but let's plot them real quick. Left 8, right 8, down 1. Oh my goodness. Right 3, up 1. 0, 3. Left 1, up 5. And back to 0, 7. Okay. Orientation. Does anybody remember what that meant? Yeah, it's kind of like the direction that we went. It started at -3. The t value gave us this point first, and then it goes around to over here. Now, it has endpoints, so we can't put arrows on the end of this because it doesn't go beyond those points. But to indicate direction, we put some little arrows in the middle of the graph here, just showing that it came around that way. That's the orientation part, okay? It's those little arrows that indicate direction. Anybody have questions about that? They don't go out at the ends, though. Okay, what were the endpoints? Well, it said one should happen when we start here at -3, and we got 8, -1. And the other one should happen when t was 1, which was 0, 7. And those will show up on the graph when we use the calculator. Okay. The only thing that's tricky is the t window, guys. When we're putting it in the calculator, the t window has to match this. So it's going to be -3 to 1. And what t step did we decide we should use yesterday? 0.1 is going to be the t step we use most of the time. Okay? It's going to be all the time on the quiz. It will work with 0.1, but I'm going to show you today a couple that you don't want to use 0.1. All right, x and y can be established simply from the graph paper. We could make them smaller because we really only care about this little picture, but the graph paper went -10 to 10 and -10 to 10, so that works for me. All right, let's show Maggie how this works on the calculator. We go to mode, and we're eventually going to need to be in degrees. So while you're in there, you can make sure you're in degrees. And then you want to turn on parametrics. Now, guys, I know I'm going to have to say this later because no one's going to listen to me right now. But later today, we want to be in simultaneous. So if you scroll down a couple more after sequential, it says simultaneous. So the three things are degree, parametric, and simultaneous. Or simul. Everybody find it? All right, now we're going to go to y equals. And I'm going to clear out a bunch of stuff. And what am I supposed to put in for the two rules? I already forgot. Was it t squared? First one? Okay. And how do you get a t? Yeah, the x button is now t because you're in parametric mode. We're in the second mode, so it's going to give us that second variable. And what was it? Minus 1. And then we arrow down, and this rule was 2t plus 5. Am I remembering what I just did correctly? Okay. Then we have to go to window because it will not give us the proper endpoints until we tell it what values of t to put in. And it was -3 to 1, wasn't it? -3 to +1 with a t-step of 0.1. And then the graph paper was -10 to 10 for x by 1s and -10 to 10 for y's. Anybody need more time on my window or on the y equals screen? And just in case, make sure you don't have any plots on up here on y equals as well. Did you get the window, Maggie, or you need more time? You good? All right, guys, let's try it. Hit graph. Now, if you didn't turn on the little bouncy bubble, you can arrow back to the left here and enter. By the way, I changed this. It was originally blue. I was having fun messing around. Ooh, orange would be good. Okay. Probably can't see yellow. Down here, though, you want to arrow to the left or right until you see that little -0, because that's the bouncy ball one. Then you arrow down and hit OK. Now, when you hit graph, you should see it. Everybody good? The bouncy ball helps me to follow the orientation if it happened to graph so fast that I didn't see it. Quick review. What happens if I make my t-step too big? Yeah, it only plots, like if I said to count by 2s, it would only plot a couple points. So it would go just a straight line because it only plotted 2 points. If I leave the t-step little, it's plotting 10 points for every value from here to here, so it makes a nice smooth curve. All right, the second thing we learned yesterday, oh, by the way, trace, okay? We can trace along here, and it tells us 8, -1 was the first endpoint. If we trace all the way to the other end, it says 0, 7 is the other endpoint. You can also look at the table and find values, but the table won't stop when it had endpoints. Everybody good? All right. We learned to eliminate t yesterday by, anybody remember? We have x equal t squared minus 1 and y equals 2t plus 5. Anybody remember how we eliminated t? Okay, we solved for t for one of them and put it into the other. Which one is better to solve for t? We're going to solve the y equation for t. You don't really want to get rid of this squared because you have to remember to square root with a plus or minus if you do that. So just solve this one for t, though. Y minus 5 equals 2t. Then if I divide both sides by 2, I have t equals this weird quantity. Everybody good? Then I'm going to put that into the x equation so that it now says x equals, instead of t, I'm writing y minus 5 over 2, quantity squared. And then it says minus 1. And you're okay to leave it like that? If you wanted to, you could square the denominator. So you would have x equals y minus 5. I'm not going to square that quantity, but it would be over 2 squared, which is 4. Or I could move it out front as a 1/4. The only reason someone might put it in that form is because that's like a sideways vertical or vertex form of the parabola. But I'm fine with this. This is great right here. Any questions about getting rid of the t? All right, guess what? There's some wonky stuff that we're going to do to get rid of t. I'm going to have you graph this equation. Okay? X equals 2 cosine, but instead of theta, we're going to use t. And y equals 4 sine of t. Guys, this is going to be weird. Please be with me here. On the calculator, go to y equals and get rid of these. And the first one was 2 cosine t. And the second one was 4 sine t. Seems weird. Now, they're not going to tell us what t is, and I'm not going to make you graph one of these on the quiz. But t is an angle. It's part of the function cosine of t. If we were in radians, we'd do 0 to 2 pi. But we actually have our calculator in degree mode, so what could we do for the window? Instead of 0 to 2 pi, 0 to 360. And again, I'm not going to ask you to do this on a quiz, but it's fun. 0 to 360. Now, wait a minute. If I told you to count from 0 to 360, would you count by 0.1s? You'd be here a really long time. If I said count from 0 to 360, you could count by 1s. I would even count by 10s, maybe. So put a step of 10 in. Again, this is not going to be on a quiz. Now hit graph and see what happens. Cool. Now it's not really a circle. Can you hit zoom square for me, which is zoom 5? And it stretches it more appropriately. What is it? It's an ellipse. It's an ellipse. I wonder if we worked on the window or with the t-step if we could make it a rectangle. I'm not going to go there. Okay. How far up and down is it going? It's going 4 above the center, 4 below, 2 to the left, 2 to the right. Okay. So here's my little graph paper. I'm going to attempt to graph it really fast, and it's going to be a little potato head, okay? There we go. It's a lovely potato head. Now, I'm going to come back to this slide, but I want you to do some work with me on number 1 right here. You have this question on your worksheet. It says, write each pair of parametric equations in rectangular form. That means get rid of a t. Well, first of all, it doesn't have a t. This was the t. Now, how do I eliminate t on this question? Anybody, any ideas? How do I solve that for t? That doesn't seem too bad, right? I divided by 3. How do I get rid of the sign? I could try like inverse sine or something, but it really doesn't get rid of the t. We're going to do something weird. Everybody paying attention because you do have to do this on the quiz. Okay? The y over here, I'm going to make it y over 2 equals cosine of t. Okay, I'm going to do a quick commercial break here. Do you remember doing this question? You added them together, the y's dropped out, and you were all happy because the y was gone? We're going to kind of do something like that. We're going to add these together and make the cosine and sine of t drop out. No ideas? Okay, I'll give you a hint. square both of these. So I get what? X squared over 9 equals sine squared. Okay, now I'm going to square the y's. So I get y squared over what? Y squared over 2 squared becomes 4 equals cosine squared. Well, you could substitute that for sine squared minus 1, but remember I talked a minute ago about how we can just add two equations together? If I add those, what happens on this right-hand side right here? It's just 1. Okay, take a moment. Moment of silence for Juan. Okay, sine squared plus cosine squared is 1. On the left, we have x squared over 9 plus y squared over 4 equals 1. Wait a minute. What is that the equation of? An ellipse. Yes? Okay, I want you to do number 2. Do what we just did to number 1 to number 2. Isolate the function. Then what do you have to do to both sides? And then when you add a sine squared to a cosine squared, you just get, I mean, I could write it out first. So it said sine squared plus cosine squared, but the rule is sine squared plus cosine squared is always just 1. It doesn't have a t even anymore. It's just 1. And this side over here was y squared over 16 plus x squared over 25. Or you could write it in the other order. It doesn't matter. But it's still an ellipse, yes? Anybody know how we could make it a circle? Instead of 4 and 5 here, what could I do? Any number that's both the same, okay? Yeah, so on my one I have typed in my calculator right now, if I made these both 4, then when I graphed it, it would be a perfect circle because it's going out 4 in each direction. All right, so there's one on the quiz. There's one on the quiz where you have to, did you put in like a t-step of 90? That's what I was thinking. I was thinking 90 because then it would only have 4 points to connect. Oh, I put it in the wrong spot? I'm recording this lesson. I should really not be messing around here. Okay. This is about inverses real quick, and then we're going to get to the meat of the lesson, which is projectile motion. Okay. Anybody remember what an inverse is? Do you remember how to write the equation, the inverse equation of this? What did we do? Last semester, inverse. How do you find an inverse? Nobody? You switch x and y, and then we solved for y. Do you remember this? And then if we graphed the first one here in blue, it would have crossed down here and done this. If we graphed this second one, it would have crossed up here at 1/2 and had a slope of 1/2, so it would have been doing this. Remember, they had to be reflections across that line, y equals x. Is this all coming back to you now? Okay. We're going to do this problem. I want you to type this in. Use -10 to 10 for t, and go ahead and put it our t-step back to 0.1. And then just do a zoom square. negative 10 to 10, 5.1. Window, negative 10 to 10, 5.1. Anybody get a parabola? Okay. We're going to do the inverse. Is it not working? Somebody's not working? Okay. We're going to go back to y equals. I'm going to do orange and black. I'm going to go down here to this one. But the idea of an inverse, guys, in parametric equation, any ideas how easy this is? What are we going to put in for the x? There was a rule for x, and there was a rule for y. When you're inverses, you do what? Switch them. So our new x rule is going to be t squared plus t. Because that was the old y rule. And the new y rule is the old x rule, 3t minus 1. When you graph it, do a zoom square. If yours does not look like an inverse, do a zoom square so that it squares up your window. It is an exact inverse. Okay, I'm going to even look at the table here. Okay, why won't my table open? Is it still trying to graph something? No? Why won't my... Here it is. So all these ordered pairs, like negative 4, 0, became 4, 0, negative 4. Do you see it flip-flopped all the ordered pairs? Ah, it is an inverse. Okay. So that's kind of cool. I don't know that it's in the homework, and it's definitely not on the quiz. All right. We are going to do this question real quick. This is on 14B. Again, I just want you to type this in yourself. Into the first two equations, I want you to put this. Into the second set, put these. And then set up this T window and use 0.1. This window. Okay? So, first of all, it just says x equals 8. And then negative 16t squared plus 90t, don't forget the t's, guys, plus 5. And the other one is the same thing. Instead of x equals 8, it's x equals t. Does this equation look familiar, guys? Negative 16t squared plus 90t plus 5. We did it with x's, and 16 was the gravitational thing, and the 90 was initial velocity, and the 5 was initial height. Remember when we did these? You did them in Algebra 2, and we did them in the quadratic unit. Okay? Now, the window, what did it say to do? 0 to 6? And then it said to do 0 to, it was at the top of the page here, 0 to 10. And then it said negative 10 to 200, didn't it? Okay. Anybody ready to see what's going to happen? I gotta go down here and turn on my little bouncy ball though, because it's much cooler with the bouncy ball. All right, watch mine and then you can try it on yours. Why is this cool at all, Hofbauer? Okay. What we did at the beginning of the year was we graphed it as a parabola, right? But we talked about it as a throw-up problem because the ball was thrown straight up and straight down. What I am trying to show you is the same graph we did at the beginning of the year can be shown in a parametric as the actual path of the ball straight up and down. Now, before we go any further, I'm going to change this number just so it'll do it again. Don't worry about it. You don't need to do it. But watch the ball. I want you to watch the two. The height is the same, right? Okay. One more time. I want you to watch my orange one only. Ready? I want you to look the orange ball and the speed at which it moves. Did anybody notice what happened? Okay, it didn't. It went up, but what happened when it got up here? Look, even now, it's slowing down, right? And then it stops, and then what? On its way back down, what does it do? Yes, it accelerates. Okay? Watch it one more time. Yeah, it's exactly the path of the ball is what it is. It accelerates as it goes towards the ground. Okay? So this is a cool way of showing that, but that's really all it is. It's still a straight up throw up problem. I want you to go back to yesterday's worksheet. Did anybody have trouble with it on their calculator? Need my help? It's not going to be a quiz question. This is going to be a quiz question. 13B. We left off with projectile. I can talk. Projectile motion. Anybody have their reference sheet out? Just so you know where this is on the reference sheet is below the unit circle. Okay. It says for an object launched with an angle theta and an initial velocity v sub 0, g is the gravitational coefficient. So you would have x equals t v sub 0 cosine of theta and y equals t v sub 0 sine of theta minus 1/2 gt squared plus h sub 0. Okay, we're going to do things in feet per minute on the quiz. So I didn't bother to make you memorize this g value. What does it say on the pink sheet? It doesn't say 1/2 gt squared. It says what? On the pink sheet, does not say 4.9 on the, well, at the bottom it does. Above that it says 16, right? Vertical position, it says negative 16 t squared. As long as you're in feet per second, this is just a negative 16. If it happens to be meters per second, this would be a negative 4.9. Okay, moving on. This is what it looks like. It has a 16 here, 4.9 if you're using meters. We're going to do this question. You ready to try this? This is the real world, guys. This is things that are kicked at an angle or hit at an angle or thrown at an angle, not thrown straight up in the air because we want it to come back down and hit us on the head. Luigi's kicking a soccer ball. He kicks the ball with initial velocity. This is v sub 0. At an angle of 48 degrees with the horizon, that is theta. The ball is 2 feet above the ground when he kicks it. That is h sub 0. All right, so on your reference sheet, it says for x, you type t times v sub 0, which is what? 35 times the cosine of the angle. For y, what does the reference say to do for y? T times 35, but then it says what? Sine of theta, 48 degrees. Does anyone think it makes sense that the x had the cosine with it and the y had the sine with it? And then it's minus 16t squared plus the initial height of 2? Everybody got those? Okay, we're going to put that in our calculator, but first let's talk about the window. T stands for time. Don't be typing yet. What kind of time does it take for a soccer ball to come down out of the air? Not very long, a couple seconds. 0 to 5 would be plenty, most all the time. So this one's less than 2, I think. But x is, guys, how far the ball goes this way. Horizontally. How far away do you think a soccer ball goes? We'll put 50 feet. Might be even more, but we'll put 50 to start. Y is the vertical, so how high does it go? 15, 20? Might go further than that. Let's try that. Okay, type it in. Don't forget the t. That's usually what I do, is I forget the t. It's t times, was it 35, guys? Cosine of 48, did I remember right? Thank you. And then the next one is t 35 sine of 48. Got to close the parenthesis this time, because then we have negative 16t squared. Just kidding. Ugh. Don't do what I'm doing. There we go. Plus 2. All right, window. We decided 5 seconds was more than enough time. It might go 50 feet away from us, and it's possible that it goes up as high. I'm going to leave this at negative 5 to 20. If you want to make it 0 to 20, it's fine. I just like to have a little room at the bottom of my screen when I hit trace. All right, graph. This time it's showing the actual path of the ball because we kicked it at an angle. Did everybody's work? Anybody got trouble? I can help. Beth, you good? All right, so if I hit trace, I could ask you 101 questions right now. I could say, how high was the ball 1 second after we kicked it? What is the highest the ball gets? How long did it take to get to its peak? How long till it hits the ground? How far away does it hit the ground? Will it clear a fence that's 5 feet tall and 12 feet away? All of those questions can be answered using this graph. The one that's asked here is, how far will the ball travel before it hits the ground? How are we going to do that? All we can do is trace, because remember, we can't change x and y's, but we want to trace until the ball hits the ground. So we want what value to be 0? Or as close as we can get. The y value, we want it to have no height. So we can get really close on this particular one. Did everybody get a y of negative 0.02? That's pretty much 0, right? So how far away was the ball? Yep, 39.8 feet away. What else does it ask? What time did that happen at, guys? Yes, it happens at about t equals 1.7. All right, so it says at t equals 1.7, the horizontal position of the ball was about 39.8 feet that it traveled before it hit the ground. How high did the ball get? Can you track that for me? What are we going to have to do? Can only go forward and backward in time, but somewhere in here it got to about what? What? You got 21 feet it went up to? Okay, it's not 21 at 0.9. Because it's the height. The height is the 12.4. And actually here it gets up as far as about 12.6. These aren't very exact answers, but it's really fun to think that it's the actual path, okay? Will it clear a defender standing 35 feet away? How would we figure that out? What do we want to be 35 feet? Okay, but what value do I want to be 35 feet away from me? How do I make that 35? I need the x to be 35, yes? Here, x, when x is about 35 feet away from me, the height of the ball is about 5 foot. Okay, so it does not clear the defender. At x equals 35, it's only 5 feet up. Okay. We can hope it hits the defender smack in the face or something. I don't know, but it does not clear the defender. All right. We're going to do at least one more together. Do you want to do throwing a ball or you want to do tennis and whether it clears the net? Which one should we do? Guys, I seriously want you to do one more of these. You want to do number 1 or number 2? Number 2. Okay. I haven't done this one today, so we'll see how it goes. Jerome hits a tennis ball at initial velocity of 38 feet per second. This is V sub 0. At an angle, this is theta. Don't get them backwards, guys, because you won't get the right answer. Okay? From an initial height of 1.5 feet, that's H sub 0. So what am I typing in for X? You go to the reference sheet, it says you put in T times V sub 0, which is 38, times the cosine of the angle of 42. For y, you put in the same thing with the sine, and then you do minus 16t squared plus initial height of 1.5. Please do this. I know it's almost the end of the day, but you need to practice this one more time. Was it 38 and 42, guys? Thank you. And the initial height was 1.5. Okay, I think my window might be okay. I'm going to try it. Did it work? Okay. I know there's one somewhere with a rocket, and you have to have a much bigger window because the rocket goes further. Before I forget to show you this, I don't think I talked about this yet, but if I had set this t small, this is what happens. Okay? Does the ball stop in midair? No, you just didn't graph it far enough out. Okay? You cut off the time it was graphing too soon. So as long as your ball time that it gets you all the way to the ground, you're good. But what did this question ask? How far away will the ball land if it's not hit by his opponent? So if we trace out there, it hits the ground. Let me show you how to get this a little more accurate. At 1.6, it's not quite there, but at 1.7, it's underground, okay? So I could trace and put in like 1.63 and see if I get closer. I really don't care. We don't have to be super close. Okay, so somewhere around 1.65, it's getting close to the ground. So it's hitting about 46.6 feet away. And there's not a lot of accuracy that has to be had on that. Okay, but the rest of the question was, at the net, if Jerome, what is the approximate height at the net if Jerome is standing 20 feet from the net? Okay, So if the horizontal distance is 20, can you make x be 20? X equals about 20, somewhere around here. So what's the height as it goes over the net? Yeah, about 11 feet. All right, guys. The homework, please, please, please. I really need you to practice this stuff. The homework is to finish worksheet 15. That's supposed to be an S. Worksheet 15 in the packet has all the bookwork on it. You are to do all of the circled questions, okay? It says the numbers on your sheet, but just all the circled ones. Those are the ones. If you don't practice this projectile motion stuff, you're not going to remember how to do all this stuff on your calculator.